Assalamualaikum and hi everyone. My name is Muhammad Nasir bin Muhammad Sabri. My matrix number is AA200976 and I am from Group MEC 14. Today, I will do a presentation about our final year project. The project title of our group is a semi-automatic fertilizer sprayer and our supervisor is Encik Muhammad Najib bin Janan. Before I start the presentation, please allow me to introduce our group members, which is consist of 3 members, namely Muhammad Haikal bin Muhammad Fauzi, Muhammad Nasrin bin Muhammad Sabri, and Alif Daniel bin Muhammad Faizal. So, this is our Gantt chart that shows the progression of the project from week 1 to week 14. So, I will start our presentation with the first chapter. This chapter talk about our project introduction. For the project backgrounds, fertilizer are essential in maintaining nutrient for the plants. There are numerous types of fertilizer, including chemical fertilizer, organic chemical fertilizer, bioorganic fertilizer, and organic fertilizer. So, we are concentrate on the liquid application because liquid fertilizer have increased in popularity in the recent years. This fertilizer can be applied either as a ground fertilizer or a foliar fertilizer. As a result, a knapsack sprayer is one method for applying liquid fertilizer. As you can see, this is a figure of a knapsack sprayer. The sprayer is made up of a tank, a pump, and a nozzle. The problem statement is knapsack sprayer are low in safety aspect. According to the Nordic Body Map questionnaires, the operator of a knapsack sprayer had muscular fatigue and pain in the leg, upper arm left, and neck. This is because the operator are affected by the lumbar pain due to the equipment weight of the knapsack sprayer in long-term usage. Then, there is a gap in the solution, especially for low-income small farmers. For example, many companies already manufacture automatic sprayer, but the purchase cost of this machine is quite high. The price tag of this type of machine starts from 7,000 ringgit. Maybe big farmers can afford to buy this machine, but small farmers will not able to buy this machine due to the high price factor. So the solution is to design a product based on the concept of repulsion and affordable. Aim of project. The aim of this project is to produce a new alternative of semi-automatic fertilizer sprayer for farmers through a low-cost design and development. Objective of project is to identify target consumer problem, needs and design requirement for the semi-automatic fertilizer sprayer, then to design and develop a prototype of the semi-automatic fertilizer sprayer, and to analyze prototype performance, structure, construction, component functionality, and development costs. For the project scope and limitation, target customer are farmers in need to fertilize in small-scale agriculture and plantation industry in the flat crop areas. So the second is the semi-automatic fertilizer sprayer, which uses the design concept of wheelbarrow and is produced from a combination of wheels, chain and gear. Okay, for general product specification, the working principle of semi-automatic fertilizer sprayer start with the wheel rotation when pushed. Then a chain connect to the wheel and gear will move the pump piston. Then liquid fertilizer will come out through the nozzle. Okay, the shape of the product consists of frame such as a wheelbarrow and a modified sprayer. The final point is a limitation. During the spraying process, this product required the flat ground. I will pass to the next presenter to present chapter 2.
Thank you, Muhammad Nasrin. Assalamualaikum and hi. My name is Alif Daniel bin Muhammad Faizal. My matrix number is AA201088. Next, I will continue for chapter 2, which is literature review for this project. For this chapter, we examine several sources relating to the history and technological evolution of fertilizer spreading methods. It began with a thorough study of current conventional approaches, and the review is followed by look at research paper, register patents, commercial solutions, other designs and developments. The evaluation examines the target consumer, general design concept, product specification, limitation, and constraint in detail. Next slide. While for history and technological evolution, manual spreaders were among the first tools used to apply fertilizer throughout history. A manual spreader is a vehicle that has a continuous web that transports manure back to a beta attachment. In 1875, the first practical manual spreader was created, while in the 1940s, dry fertilizer components were made for direct distribution by spreaders. The late 1950s marked the start of a new era in the liquid fertilizer business. And furthermore, to properly disperse these fertilizers, a newly designed instrument is required. And besides, to assist the movement of a fluid, many types of pumps are created. And for examples, centrifugal, diaphragm, and piston pumps. Next slide. While for research paper parts, the occupational research on sprayer operation was carried out in order to identify a solution to create a tool that mesh between man-machine system. The research paper of this method is to discover a way to reduce the operator's tiredness and suffering. Nordic body map surveys were distributed to the knapsack sprayer operator. The operator experienced muscle wearings and soreness in his neck, upper arm, left leg, and foot. According to the research, the suggested resting time to knapsack sprayer operators is 125 minutes for every hours of working time. As a result, um, improving the equipment for spraying fertilizer may be the greatest way to increase quality. And based on the picture in the slide, it is a wheel-driven pull-type agriculture sprayer. According to our research, this equipment is intended for small-scale farmers to spray chemical liquids such as fertilizer. This machine is a low-cost instrument for spraying fertilizer in agriculture areas because there is no need to carry on the back, and this device also alleviates back strain. And also this equipment is constructed with a greater number of nozzles to cover a larger area of spraying in less time. Finally, the operator can cover the 5 parallel rows without becoming fatigued. Next slide. Register pattern. A portable agriculture sprayer is one of the registration patents we acquired. It is made up of a small elongated wheel frame with wheels that are tightly placed for operating between plant rows. For hand movement, the handle is linked to the frame. The compressed air is supplied by an electrically driven compressor and is powered by electric storage batteries. The storage tank is linked to the frame carrying a fertilizer solution and is connected at the end to the compressor output side to be supplied with compressed air for pumping the liquid. Next slide. Commercial solutions. For this part, through our research, there are many types of fertilizer spray that can be a solution for ergonomic problem of knapsack sprayer. This product is suitable for residential and commercial use. For example, toad dripless fertilizer, fertilizer three-wheel drive tractor boom sprayer machine, and fertilizer drone. Next slide. I will go through to explain about the other design and development part in chapter 2. The innovation event is one method for determining the best solution to solve the problem. The National Grassroots Innovation Event was conducted to discover a solution to the pesticide spraying problem. For example, Mansuk by Jagani mounted the sprayer on the conventional sprayer. This innovation is adaptable since it takes up less space to move. Next slide. I will continue to present about new innovation potential. Farm operators are generally the consumer of liquid fertilizer sprayers. The design concept consists of a tank, nozzles, and pressure chamber. The general design of the knapsack sprayer is small and portable, but have a low capacity of liquid and lead to ergonomic issue in long-term usage. From the observation of the current product, this innovation of semi-automatic fertilizer is operated by pushing rather than carrying at the back. Furthermore, and this innovation also consists of fixed nozzles that can be adjusted the height, and this tool is suitable to use in flat area. Next, I will pass to the next presenter.
Hi, my name is Muhammad Haikal bin Muhammad Fauzi, metric number AA200264. So I will continue this presentation with the methodology session. So some important points are emphasized in this section, such as tools and equipment, data collection method, data analysis method, and development cost. So this project starts with design formulation, followed by concept design, product architecture, and configuration design. Then during parametric design stage, part sizing and product assembly drafting is produced using SolidWorks software. The procedure continues with material selection. Project methodology for initial report ended with analytical design analysis. So before fabrication process, SolidWorks software are used during parametric design. So the material of every component are evaluated in SolidWorks during the design process. In addition, dimensions are also evaluated on the model according to the measurements. So this gives a clear understanding of the models that want to be produced during the final year project 2 later. So data collection is defined as the procedure of collecting, measuring, and analyzing the information using standard validated techniques. The informations are collected from previous research papers related to the scope of project. The collected information are about the problem of current tool to the operator, the type of the fertilizer, the approach to solve the solution, and lastly, the type of the crop. Related information also collected by market study. So online shopping websites can be a medium to collect the data, such as Alibaba, Shopee, and Amazon. So other than that, market study also can be doing from the hardware shop. The collected information included the range of price for current product, the working principles, and lastly, the specification of the products. So analytical analysis are used to know about the engineering principle in this project. The mathematical equations are used in this process to get a better understanding about the behavior of the tool. The figure shows the estimation cost for this project. So the cost for every component are based on market research such as from online shopping website, which is Alibaba, Amazon, and Shopee, and also from hardware shop.
Okay, I will continue the presentation by presenting chapter 4. Okay, in this chapter, it will talk about result and discussion. Okay, problem definition. For problem definition, Knapp's sprayer is one of top choice for small-scale farmers and other applicators in agriculture, but it has potency on all computational health and safety problems. For example, the potency is muscle pain. It is caused by sprain and dislocation because of repetitive motion, lifting overload, and awkward posture while wearing a knapsack sprayer. Then, static loading by carrying belts or strap can block blood flow in the muscle and can lead to a decreasing ability of muscle contraction. Other than that, muscle overexertion can cause fatigue and inflammation in the muscle and joint. It will cause a level of severe cumulative trauma disorder, such as tendonitis. It happens if the operator work in high frequency and less rest periods. So, we can conclude that there are many problems from the conventional sprayer to the operators in long term of usage. Need assessment. Need assessment is a gathering and analyze data of customer requirement from various related sources from literature and market research. This assessment divided into two parts, which is demand and wishes. So this table figure is shows the table for demand requirements, and we got 15 demands for our project, and the demand is low maintenance, easy to control, stable, and others. So this is a figure for wish requirement. For wish requirement, we got 10 wish requirement for our project, and the is pneumatic tires, pressure gauge, filter under the caps, and others. This is design objective 3. The design objective 3 is a diagram that can help explain the design objective to meet the needs of the customer in a clear and concise method. As you can see, in this design objective 3, it has 4 important objectives for semi-automatic fertilizer sprayer project. The important objective is safety, economical, convenience, and quality. Okay, for safety, it has no sharp corners and low noise. And then for economical, it has a low maintenance cost, energy efficient, and affordable to buy. For convenience, it has foldable head nozzle and many nozzle for spray fertilizer and easy to clean. And the lastly is quality. It has a constant spraying flow. Product design specification. Product design specification is technical design aspect. In product design specification has information on customer requirements, company requirements, engineering characteristic, constraint, and customer satisfaction. So this is our product design specification. The title is semi-automatic fertilizer sprayer. The design problem old product which is knapsack sprayer is heavyweight during spraying and the operators feel very tiredness and fatigue which reduce his efficiency. Then for a new idea of our product which is the semi-automatic fertilizer sprayer, we increase the functional performance where it can carry a large tank that is 16 liter in size and also easy for handling because it has ergonomic grips and have many nozzles that can provide a wider spraying. Then for pollution, this product does not pollute the environment because this fertilizer not use any engine and free of carbon emission. Next slide. I will pass to the next presenter.
Thank you, Nasrin. Next, I will continue about the concept design parts from chapter 4. Concept design is the stage of a product's evolution in which different design concepts are produced, assessed, and chosen for future development. The concepts are just in an abstract form to allow for the freedom to produce various concepts, and they must also match the requirements listed in the product design specification, which is PDS. This stage includes three activities: product component decomposition, product concept development, and alternative concept evaluation and selection. Next slide. Product component decomposition. Product component decomposition is a process that involves producing block diagrams of the sub-assemblies that comprise a product. This activity is meant to offer a broad grasp of the interaction of separate components with each other as well as to roughly describe the hierarchical structure of component forms. During this stage, information obtained from the literature and market research was utilized. And as we can see from this slide, it is a product component decomposition for a semi-automatic fertilizer sprayer, which is separated into 7 components as well as its minor component breakdown. Next slide. Product concept development. At this stage, many alternative concepts generated for each sub-function of product components decomposition. Morphological metric is one approach used to generate these alternative concepts. This method starts with listing the sub-assemblies in a column of a matrix and the alternative concept for each function in adjacent rows as shown in the tables below. Next slide. Alternative concept evaluation and selection. Once various concepts have been created, the most relevant concept must be chosen to match the requirements outlined in the product design specification, which is PDS. To begin, some of these alternatives will be phased out if they do not match consumer demand or are not eligible for removal. The image in the presentation depicts a concept group for as many potential possibilities as visible. During the next review step, this sketch will be used to represent the alternative product structure. We have made 3 recommendations for the design of semi-automatic fertilizer sprayers. After that, weighted rating method used as the evaluation criteria. Weightage rating used based on the importance level of criteria. Furthermore, the concept alternative with the highest rating is the one that most closely satisfies the set design criteria and will be selected as design concept. Next slide. I will go through explain about the product architecture. The initial step of embodiment design is product architecture, which is followed by configuration design and parametric design. In general, product architecture is concerned with the selection and organization of functional elements and components of a product, whereas configuration design is concerned with the selection and arrangement of configuration features for product components. Parametric design, on the other hand, is the process of developing a strong design and deciding on final dimensions, parameters, and tolerance. This procedure must be complemented by a series of evaluations to determine whether the current design concept is still viable. Iteration is frequently necessary, and furthermore, product architecture also is the arrangement of products' functional parts into physical building pieces, which is components, subsystems, or sub-assemblies that interact with one another to fulfill the overall function of the product. The architecture of a product might be modular or integrated. Each functional element in a modular architecture is realized by exactly one physical chunk, whereas integral architecture based on product functional components is implemented by more than one chunk. As we can see from the slide, there is a comparison between modular and integral product architecture for our group's project, which is semi-automatic fertilizer sprayer. I think that's all from me. I will pass to the next presenter. Thank you.
So I will continue for the parametric design. At this phase, design variables which refer to specific size and material type. Manufacturing requirements are determined based on selected configuration design. Then, design analysis is used to predict the performance according to the engineering principle to ensure the design is feasible and achievable. Configuration design goal is to specify the best configuration feature of the design and associated modules to meet their intended function. As the second stage of embodiment design, it should consider all related engineering principles, working geometry, and material in order to solve design problem. So each configuration needs to be identified and evaluate its capability level of achieving functional and stated design requirement using weighted rating method to select best configuration among various alternatives. The first stage of parametric design is part sizing and product assembly drafting. This process is conducted in order to visualize latest configuration of product assembly and its component. So all parts will be preliminarily identified, its size, and drafted using SolidWorks software. General product size should be notified in this drafted drawing. During conceptual and configuration design, only some general assumptions are made based on basic properties and general usage of the material. Selection of specific material for each special purpose part was conducted as product design develops during parametric design phase. There are three main things during choosing the material, which are the material need to meet the performance requirements, the material is easy to process, and lastly, the material have right aesthetic properties. Metal-based materials are used in this project. The different metal strengths need to be considered. Among them are tensile strength, impact strength, and compressive strength. Other than that, there are three options of material for the tank, which are steel, polypropylene, and polyethylene. From the options, the most suitable material for tanks are made from polyethylenes. So this is because the tank made of this material is compatible with chemical liquid, lightweight and easy to handle, impact resistant and corrosion resistant. Then, the selection from components manufacturing method. For the frame, we can fabricate by using cutting machine techniques. Other than that, the components such as tank, pump and nut can be found from the store. This component can be assembled by using non-permanent joint. Analytical method in this project use formula from physics, mathematics, or engineering science to predict performance of product designs. The equilibrium of forces and moments are used to determine the force that must be applied to operate the tool. We can analyze it by drawing a free body diagram of the semi-automatic fertilizer sprayer.
So that's all from our groups, and if there are any question or something you not understand, you can ask in the question and answer season. Bye, thank you.